Welcome back guys to Mathematical Mindset. So right here we have this nice algebra math question that says 3 raised to the power of x plus 9 raised to the power of x plus 27 raised to the power of x is equals to 39, and we are to find the values of x. So right here guys, I'm going to share with you two methods. Now the first method is a very easy and direct method to find the real root of today's question, while the second method is to find the real and complex root of x right here. So guys, let's simply start in with method 1. Alright, so for method 1 right here, all we have to do is to simply do this. We have 3 plus 9 plus 27, and this is all raised to the power of x, and this is equals to 39 all raised to the power of 1. So 3 plus 9 plus 27 is going to give us 39 all raised to the power of x, and this is equals to 39 all raised to the power of 1. So since the bases are the same, all we have to do is to equate the power. So hence from this we have that x is equals to 1, and from this we have been able to find the real root to this question. But for method 2, we are going to apply a different approach altogether. So for method 2 right here, we have this question. So all we have to do is to simply express 9 and 27 in terms of 3, and if we express 9 in terms of 3, we have this to be 3 squared, and if we express 27 in terms of 3, we have this to be 3 raised to the power of 3. So from here we have this to be 3 raised to the power of x plus 3 all square raised to the power of x plus 3 raised to the power of 3 all raised to the power of x is equals to 39. From the property of exponents, if we have a raised to the power of m or raised to the power of n, this is the same thing as a raised to the power of n or raised to the power of n. So expressing this, we have this to be 3 raised to the power of x plus 3 raised to the power of x all square plus 3 raised to the power of x all cube, and this is equals to 39. So from here, we're going to say let y be equals to 3 raised to the power of x. So from here, we have y plus y square plus y cube, and this is equals to 39. But 39 can be expressed as 27 plus 9 plus 3. Okay, so we have this to be y plus y square plus y cube, and this is equals to 27 plus 9 plus 3. So rearrange and set the equation to 0. We have this to be y plus y square plus y cube minus into 27 plus 9 plus 3, and this is equal to 0. But we can express 27 in terms of 3 as 3 raised to the power of 3, express 9 in terms of 3 as 3 squared. So from here we have this to be y plus y square plus y cube minus into 3 raised to the power of 3 plus 3 raised to the power of 2 plus 3, and this is equals to 0. So open up the brackets, we have y plus y square plus y cube minus 3 raised to the power of 3 minus 3 raised to the power of 2 minus 3, and this is equals to 0. So we can easily rearrange this to be y minus 3 all in brackets plus y square minus 3 square plus y cube minus 3 cube, and this is equals to 0. We want to simply apply the difference of cubic formula and the difference of square formula. The difference of squares formula is given as if we have a square minus b square, this is equal to a plus b multiply a minus b. But if we have the difference of the cubic formula is a raised to the power of 3 minus b raised to the power of 3, and this is equal to a minus b into a square plus ab plus b square. So we have this right here. So from here up to this point, we are going to have this to be y minus 3 plus, now for y square minus 3 square, this is going to become y plus 3 multiply y minus 3 plus, now for y cube minus 3 raised to the power of 3, whereby we have a to be y and b to be 3, this becomes y minus 3 into y square plus y multiply 3 plus 3 square, and this is equal to 0. So we have this to be y minus 3 plus y plus 3 multiply y minus 3 plus y minus 3 multiply y square plus y multiply 3 is 3y plus 3 square is 9, and this is equals to 0. So we want to simply factor out the common term, and the common term is y minus 3. So we have y minus 3 into, so if you factor out y minus 3 from here, we have this to be 1 plus y plus 3 plus y squared plus 3y plus 9, and this is equal to 0. So from here, we have this to be y minus 3 into, so I'm going to rearrange this. We have this to be y squared plus y plus 3y plus 1 plus 3 plus 9, and this is equals to 0. We have y minus 3 multiply y squared plus y plus 3y will give us 4y plus 1 plus 3 plus 9 is going to give us 13, and this is equals to 0. So from here we have that y minus 3 is equals to 0, and we have y squared plus 4y plus 13, and this is equals to 0. So y is equals to 0 plus 3, and y is equals to 3. Why for this, we want to simply solve using quadratic formula. So solve using quadratic formula right here, and we have the quadratic formula to be y equals to minus b plus minus the square root of b squared minus 4ac all into 2a, and we have a is equals to 1, b is equals to 4, and c is equals to 13. So y is equals to minus 4 plus minus the square root of minus 4 squared minus 4 multiply 1 multiply 13 divide 2 multiply 1. So we have y is equals to minus 4 plus minus the square root of minus 4 squared is 16. 4 multiply 1 multiply 13 is going to give us 52. Divide 2 multiply 1 is 2. So we have this to be y is equals to minus 4 plus minus the square root of 16 minus 52 is going to give us minus 36 over 2. So y is equals to minus 4 plus minus the square root of 36 multiply the square root of negative 1 over 2, and y is equals to minus 4 plus minus the square root of 36 is 6, and the square root of negative 1 is I. Alright, and this is over 2. So we factor out 2 from the numerator. We have 2 into minus 2 plus minus 3i over 2. So this is going to cancel out this, and we have that y is equals to minus 2 plus minus 3i right here. So we have been able to have the values of y. So from here, we're going to say hence we have that y is equals to 3 and y is equals to minus 2 plus minus 3i. But recall that at the beginning we said let y be equals to 3 raised to the power of x. So working with the real roots, so we have 3 raised to the power of x is equals to 3, and this is raised to the power of 1. So since the bases are the same, all we have to do is to equate the powers. So therefore we have x is equals to 1, and this is the value of x. Now for the other part, we have this to be 3 raised to the power of x is equals to minus 2 plus minus 3i. So taking the log of both sides, we have log 3 raised to the power of x is equals to log into minus 2 plus minus 3i. So applying the logarithmic property that says if we have log a raised to the power of b, this is equals to b log a. So applying this property, this becomes x log 3 is equals to log into minus 2 plus minus 3i. So dividing both sides by log 3. So if we divide this by log 3, this is going to cancel out this. We have that x is equals to log into minus 2 plus minus 3i over log 3. Now applying the change of base formula, if we have log a over log b, this is equals to log a base b. So applying this, we have that x is equals to log base 3 into minus 2 plus minus 3i, and this become the other value for x. So guys, these are the two methods in which you can use to solve this question right here. Alright, so with this guys, I'm going to see you in the next video, and if you are not yet subscribed to Mathematical Mindset, please do it, tap onto that subscribe button